please start the program. Dr. Pooja is here.
Hi, Musti. How are you?
Fine, fine. Thank you, sir. Thank you for joining. Welcome to all of you. Dr. Vandana or Dr. Pooja, please start the program.
Good morning, all. Hello, Pooja, are you there? Pooja? Problem is there.
She is not here. Probably Dr. Vandana or Dr. Lakshmi Kumre, you please start the program.
Lakshmi, are you there? Okay. Good morning, all.
Hello, good morning.
Good morning, sir. Good morning, Shastri sir. Good morning, Sindal sir, all the participants, respected guests, and my colleagues. A very warm welcome to this two-day virtual national conference on next generation communication technology. I request all the participants, please mute yourself because a lot much noise is coming. Thank you all. Now it's my privilege to introduce our guest, respected Shastri sir. Very good morning to you. He is a renowned personality. He is from Department of Electrical and Computer Engineering, Namibia University of Science and Technology. I welcome you, sir, for this for being a guest in our two-day national conference. Very briefly, I will read the biodata because there is a huge thing to tell you about. Please mute all the participants yourself, please. Okay, thank you. Dr. Shastri has done PhD in electrical engineering from NIT Warangal, Kakatiya University, India. He did his MTech in power system engineering from NIT Warangal. He did his BTech in electrical and electronics engineering from Kakinada GMT University, Hyderabad. His professional experience is very rich. He had been Associate Professor and Deputy Director, Department of Electrical and Computer Engineering. He has also been visiting professors to various reputed universities. His current responsibility is he is doing his research and development renewable energy systems, and he is also officiating with Namibia Energy Institute as a research lead for two projects, demand side management and energy efficiency. He had been a program coordinator, PG coordinator in the department, and also a program coordinator in Trinidad and Tobago. He had been a head of the department KITS India. He has been a assistant general manager GEC India, and too much like he has done whatever he has done a lot in his professional career. He has also been having some internationally funded projects. He is being busy with his research for these projects. He has memberships and professional registrations in various reputed professional bodies, and his research career is also very like impressive. So he has a good number of publications with good impact factor in reputed journals in international and national conferences, and around 50 papers he is having. He has also written number of book chapters, around 7 book chapters in very good publications. And one more thing I would like to add, that his words of wisdom will really motivate the participants and make this event a great success. I invite you, sir, and welcome you for this two-day national conference. Please,
just a minute. Let me introduce.
Okay.
Let me welcome all the participants. So, on behalf of organizing committee, I am Professor P.K. Singhal. Welcome to all the experts available here, Dr. Rashmi Bharadwaj, Dr. Shastri, and Dr. V.K. Jain, and Dr. Anupam Vyas, Dr. G.S. Tomar, Chairman, basically MP subsection, and all the dignitaries who joined here today morning on behalf of IET Bhopal Center. I welcome all the participants here. I shall tell briefly about this conference. This conference is being organized with the Association of IEEE MP subsection, IET Bhopal Center, and IET Gwalior Center, along with Institution of Engineers India, Gwalior chapter. And for this conference, we have received very good response, large number of papers. And being the two-day event, it was not possible to accommodate all the papers. So we did scrutiny, and all the papers were of very good quality. So only limited number of papers we have selected for presentation. And for this conference, we have very eminent persons as the keynote speaker and session chair. So our chief guest, Dr. Chaudhary, is not able to join, probably due to connectivity, because he is from Uttarakhand. Dr. Tomar, is he able to join?
Then he's on the way, so he's not getting signal because he was
Oh.
on hilltop in some institute visit and he's on the way.
Okay,
So if he is able to get
whenever,
signal, then only he will be joining.
so whenever he will join, we shall request him to deliver his address. In the
He will join as and when he gets signal.
Okay, fine. So in the meantime, first of all, I request our guest of honor, Dr. Rashmi Bharadwaj, who is the motivating factor for this conference and always supporting for all of our activities. I invite Dr. Rashmi Bharadwaj to say a few words. Dr. Rashmi Bharadwaj, please.
Thank you. Thank you, Professor Singhal, Professor Shastri, and all other dignitaries. I feel welcomed and honored that this responsibility is given to me. And of course, this is new challenges and next generation, because this is a communication technology we are talking about. And this is a combined effort or collective effort of all the organizations which are working in this field, and specifically IET, IETE, and all the MP sections. Basically, before starting, what is generations, or what we can talk about the communication technologies. Actually, till now, if we talked in details or in a short, there are the four technologies or four generations, I can say that, which create the history, which create the changes in the industrial revolutions. So we have the four industrial revolution. The first industrial revolution started in around 1760, when we have the changes in a mechanical changes, means that the engines comes into the pictures, the steam engine come into the picture. So that is a one complete industrial revolution in the year 1760, which remains around up to, means the generation is still there, but the major changes comes there from 1760 to 1840. Then the era of the, I can say, the electrical changes or electrical revolution or electrical industrial revolution, which is we know as a industrial revolution 2, which comes into the picture where the all the electrical changes, means the transmission or the electrical composition or electrical transformation and all those things took into part. Then now the era comes about the conductor chips formation and the, we can say, the computer revolution or the computer industrial change. And now we are in the era of the industrial 4, where we have cyber physical systems, and that how the computers communicate together with the physical system. So we are mostly going towards the era which is totally dependent of internet of things, artificial intelligence, blockchain, machine learning. So these are the era which is the coming present era. So if we talk about these things, then the mostly thing we talked about, because now we are not doing a physical processes, we are depending on the that how we can communicate. So I can coin a one term which is a digital twins, which is a very commonly used in the European country. Last year I was in US. So they coined a European countries digital twins, that they are doing a digitization instead of the physical processes. So all the processes whichever they are using, so before that they are doing the digitization, and then based on that they are doing or working it. So I will try to put some of the slides to show you something about that, what is that, and how this industrial revolution is going to be change the present era. So before starting, I would like to talk about the something about that how these things are going to happen. Uh, is it visible? Hello. Hello.
Yeah, ma'am, it is.
Not yet visible. You go to the bottom and presentation now.
Just a minute.
Move
Yeah.
Dr. Bandana, please guide her. Dr. Bandana.
No, I have that one. And just a minute. Just give me a 1 second.
Sure,
Yes.
sure, sure.
Please see the right side of the window. There you might
Yeah.
find the share screen.
It is showing, but the screen is not coming. That's the problem. Now it is showing. I think now it is showing.
Yes, ma'am.
Yeah.
Not yet started, madam. Not yet started. Yeah, yes.
So so basically, as this conference is based on the next generation technology development, so what we are working, or how much time it is take to change the revolution in the form of the industry. So as I said that earlier three industrial technological revolution is, first is in the mechanical production, where we are working on the railway steam engine. So that is the era from 1716 to 1840. Then we have a mass production on the electricity and assembly line, which is from 1870 to 1940. Now we have an era of computers, means a semiconductor, mainframe computing, personal devices, internet, which is a 1960 to 2010. But now we have a cyber physical system, which is the industrial 4. So these are the technical revolution. So right now, presently, we are in the cyber physical systems, where we are working on Internet of Things, artificial intelligence, machine learning, blockchain, and the different combination of these processes. So what is the industrial revolution or industry 4.0? So basically it is a collective term for technologies and concept of value chain organization based on the technological concepts of cyber physical system, the Internet of Things and the Internet of Service. It facilitates the vision of the smart factories. So we are presently working on the smart factories of Industry 4.0, which is a cyber physical system which monitor the physical process, create a virtual copy of the physical world, and make it as a decentralized decisions. So over the Internet of Things, cyber physical system communicate and cooperate with each other and humans in real time. Via Internet of Services, both internal and cross-organization services are offered. and utilized by participants of the value chains. So now we are working on builds on the digital revolution, smaller and powerful sensors, machine learning, internet, artificial intelligence, labor and energy cost. So optimization of the technology with the energy cost and the labor productions. If we talked around the era in the year 2006 or 2008, then these things didn't exist in the like iPhone. Means I'm talking about the more about the Indian context. iPad, Kindle, 4G, Uber, Airbum, Android. So these are the things WhatsApp or Snapchat. How much time take the means basically how much this industrial revolution took place or how much it will reaches to the masses. So if we talk about the time to reach 100 million customers, if we talked about the telephone, it takes 75 years. If we talk websites, it took 7 years. Facebook took 4 years. Instagram took 2 years. But to surprise, Pokemon goes to the in a 1 month to the reach of the 100 million customers. So these are the industrial changes or industrial revolution and how it will cover the masses. This is important. Recently in the physics, we got a Nobel Prize on the time arrow where the concept of time arrow came into the pictures. And we feel proud that Professor Ray Chaudhry's equations are used for this Nobel Prize. So basically, actually, everything is going only in a one-way direction or a symmetry of time, which is known as a arrow of time. And it was developed in 1927 by British astrophysicist Arthur Eddington. And it is remains as an unsolved general physics question, which was solved now in this year, and we got the Nobel Prize on this arrow of time. So I'm not going in much of those, but these are the three T which remains as per the Stephen Hawking's perception. Psi T, which is a human perception of time. Then we have ENT, which is moving means entropy time. And next is the cost, which is making that how much framework of time very much. And but this arrow moves forward when the universe is in a inflationary state. So basically, these are the some things which is the that about the universe that eggs breaks, ice cubes melts, but radiation starts emitting. But we cannot go to the back of these ones. Like milk spills but does not unspill. So these are the time irreversible or arrow of time of the concepts. So based on these, if we are talking about, there are the 7 arrows of time, and these are important. First is the memory arrow. We only memory works only in the backward direction because we don't remember the future. Same way, another one is the electromagnetic arrow. Then the quantum arrow is there. Black hole arrow is there. Means black hole exists, but white hole does not exist. Then we have the cosmological arrow, con arrow, or entropy arrow. And this is the last one. Total entropy always increases. And this is the major reason for the changes or the for the industrial development or the for communication generation. And this is the main important that new world would be indistinguishable from the old world. As I shown you that for me reaching up to the millions of people, it took only 1 month as compared to the 75 years. So we always moved in the forward direction as time arrowed in the similar direction. Now we are in the era of the 2020, and recently we are all are suffering with the pandemic conditions. So our research, our industrial development, everything has drastically changed along with time. So like research changes education and education further changes the research. Simple example is C language developed on the Unix operating system, and Unix developed and C language changed accordingly. So basically we are changing the system as well as education again change that system. that COVID-19 changes the world forever for these six important factors, like globalization. We all know that comes into the halt. Healthcare now goes digital. One of my scholar is going to present on the application of blockchain of COVID-19. Then we have a e-commerce. Now it is more on the practice. We start travel, tourism, and layer, but it is also in the halt because we are thinking again. Real estate existential caution is still there. Climate change efforts in the balance. These are the all the things which are on the halt due to the this, or we changed that due to the COVID-19. So as we are talking about the cyber physical system, we know that it is a system which has the communication, computation, information, and control. So basically, it is a physical and engineered system whose operations are monitored, coordinated, controlled, and integrated by a computing and communication core. So which allows us to add capabilities to the physical system and the communication with the physical processes. Like if we are talking about the today's practice, so there are the different components are making at the different parts. So like a workstation, one is in the car manufacturing, making a base, then the another one is making a top, the third one workstation is making the engine or wheels, and the fourth is fitting the seats, and then it goes to the out as the market product. But if we are talking about the tomorrow's factories, as per the industrial revolution, so we are fixing all this together, and then it comes out to be the, so all are working in a integrated manufacturing system as a simulated one. So these are the six design principles which we are working. Of course, interoperability, virtualization, decentralization, real-time capabilities, service orientation, and modularity. So these are the components for our industrial, or the, you can say, physical communication. Virtual manufacturing system, which I can coin as a digital twins, data analysts, cyber physical system, robotics, virtual reality, cloud computing, big data, Internet of Things, blockchain now is also a part of this. These are the some impacts, because now with this all this pandemic also, governments, country, regions, international securities has the impact of these cyber physical processes. Society also has the inequality and communicating. Individual also has the impact of these ones. So these are the structure for all intelligent monitoring system on which I think that this conference is working on. We have the raw data, then different type of the web services, then how these are working in together with the base of the cloud computing, application servers. And this is the, which I said that digital twins. Actually, physical object is different, but we are replica it with a digital twins. So it is a replication of physical world with the digital world. So why we are using it? Digital twins basically incorporates the big data, artificial intelligence, machine learning, Internet of Things, and blockchain. And this is the concept which has the, means you have the data, then each physical thing has at least one unique twins. We model it, we control it, monitor it, analyze it, or the simulate it. So this is the kind, means that is the main project here in the European countries about the automation industry. So there they are not using the cars or for the development, means like for the checking of the accident, when that how much time it will take, minimization of the time or optimization of time for putting the brake. So they are using, and that is the million or trillion project on this based on this digital twins. So digital twins is basically a replica of the physical world, and which is nowadays we are using all So it is the product development life cycle, right from the design phase to the development phase. So instead of having physical processes or working on these, like because during all the pandemic, so we are working on the digitization of those processes. So it has a business concept, business model, as well as economic architecture. So economic value of the future would involve, of course, the field service engineer on a virtual machine without having a dedicated trainer or simulator. Same way, artificial intelligence and machine learning would make machine autonomous, self-optimizing, able to diagnose, heal, and repair themselves. And in this field, these are the process, and of course, we are responsible for all this security and overall functionality. Application is in all processes. So clearly, what is needed is a comprehensive portfolio that empowers the enterprises to excel at the fundamentals of digital twins or the physical processes by enhancing the core to create a culture of continuous improvement and innovation like never before. So these are the some digital twin enabled business models. And this is the scope of these ones, that you have intelligence, then it goes to the customers, ecosystem, Internet of Things, Internet systems, and that how we are calculating these ones. So how we are monitoring and then processing these ones. So I'm only not taking, these are the something which has 4 best practices to avoid digital twin failures. Innovation insight for digital twins. Then we have the IoT platforms, hype cycle for the Internet of Things, digital twins which impact the economic and business models. So main challenge is to cover how the Internet of Things, robotics, artificial intelligence, machine learning, blockchain, analytics, virtual and augmented reality, 5th generation, and a range of other technologies are transforming, connecting business and making organization of every size more efficient, productive, and profitable. So I think this is the purpose of our conference also. So I'm not going in much detail. Only I'm showing that this is the future, like a merger sponge we are using, which shows that how till date we are using 64 million cubes, or which gives you the dimension as only 1.67. So this much information we are able to gather together. So these are the application, any field you can choose, and you have the application of this communication technology. So only in the last, I will say that to the participant that they must enhance their personal creativity by accepting that there is no right answer. Don't follow any rules. Be foolish. Always ask what if. Think outside your area. Go for ambiguity. Believe in yourself. So any technology development is, of course, based on the integrity, means the implication of that, positive attitude, honesty, motivation, sincerity, inspiration, commitment, hard work, and then you can use those type of the technology. Success has only an amazing formula. Stop thinking in terms of limitation and start thinking in terms of possibilities. And it suits to Professor Singhal, that he always thinks a new creativity about the this. So almost every successful person begins with 2 beliefs. The future can be better than the present, and I have the power to make it so. So be successful. And the another one is, I do hope that we, as the futures of tomorrow, make a difference to somebody's life. So all the best for, and I like this quote of Picasso. I'm always doing that which I cannot do in order that I may learn how to do it. So every time we are learning in the process of that. And with this, I can say that the best of luck for this conference. And process of these ones, and it will go to change because the topic already chosen by Professor Singhal is need of the present era, and he is always, I think, on the toe, and always his mind is on that. So with these words, I will say only that thank you for giving me the opportunity, and as the best of success for this conference, and of course the participant will learn most of the new things with this conference. With these words, I will say thank you and giving me this opportunity. Thank you once again. Thank you.
Thank you, Madam. Dr. Bandana. Okay. So thank you very much. Again, I welcome all the participants who joined later on, and I am able to see from the participants there are Pakistan also, and a few are from Nepal also. So I welcome all of them. So now I request Dr. Sastri to please start the presentation. Dr. Sastri, please. Dr. Sastri, are you able to listen us? Dr. Sastri, please start your presentation. Dr. Sastri, are you able to listen us? Are you hearing us?
Hello.
Dr.
Sir, Dr. Shastri has put up a message that he is not able to hear. Audio is not there on his end.
But we are getting his voice, so probably.
Please contact him on mobile or something and tell him.
Hello, good morning, everybody.
Good morning, good morning, good morning. Yes.
Hello, good morning.
Good morning, good morning. We are able to listen to you, sir.
Good morning, everybody.
Good morning, good
I
morning,
am not
sir.
hearing your voice.
But we are listening to you, sir.
Hello.
Singhal sir, can you contact him on mobile and tell him that we are able to listen his voice?
I shall try my best.
Yeah, because it looks like a one-way communication.
Yeah, I shall let you talk to him.
Probably his speaker may be mute. He has to do unmute.
Hello.
Hello, yes.
Hello.
Or he can re-log in. He can disconnect and re-log in again.
Good morning to everybody. I believe my PowerPoint is visible to everybody. My apologies, I am not hearing the audio. My speakers are fine. My systems are fine. I am in my office from in Windhoek, Namibia. We are close to South Pole. I wish I could hear you. I am not hearing your voice. My systems are very good, and I do not know what is going wrong here. However, apparently, my only feedback is okay. Thanks, Professor Singhal. Sir, he is confirming that we are listening you. So, though I am not able to listen your audio, I will continue with my presentation. At the outset, I would like to thank the conference organizers for giving me this opportunity. Let me quickly introduce myself. I am Professor Musti Sastri. I just got a little audio, but I don't know if it is being sorted out. Anyway, I am now Deputy Director and Associate Professor with the Department of Electrical Engineering, Namibia University of Science and Technology. And I work jointly with the university and the World Bank here. And recently I am appointed on the board of ADB, African Development Bank, also in energy sector. This lecture is basically, though I deal with energy management, I would tell you, all of you, which is the crux of this presentation, the aspect of electrical energy is only 5 to 10%. Rest of the 95% is all about 4.0, IoT, big data, and also data visualization. These are the aspects we are dealing with. I have been dealing with Industry 4.0 for the last 5 years very actively. I even visited Gwalior, Bhopal, and gave lectures also. So let us get through the lecture. I wish I could kind of have some interaction with you before I start with you all, before lecture starts. But anyway, let us go on without wasting much time. I will keep my lecture very simple and concise and all that. I have a demonstration also to give the audience a kind of idea about how the big data is processed and why it is very important in energy engineering and all that. So this lecture will not have much on energy side. It is more on IT side only. So first we look at, to understand, we look at what is energy 4.0 and why we need industry 4.0 for energy 4.0. And then we have one what is called demand side management, because the situation is so complex, and we have what is called demand side management concept. I will explain within 1 or 2 slides. And what I have done so far here at NUST, elsewhere in the world and all that, I have visited, I have worked in different parts of the world, France, Japan, India, and Trinidad and Tobago, and US and Canada. And then I will bring up some experiences and all that, and I will do a demonstration and then conclusion and all that. It won't be very long. I know my time. Now, okay. This lecture provides insights into requirement of IT tools and energy planning, and then planning strategies, a little bit of energy economics, and computing and visualization opportunities and research opportunities. That is what we deal with. Just let us look at energy mix within 1 or 2 slides. Gone are the days where we depend on fossil fuels. There is a lot of coal. There is a lot of renewable energies being pressed in. I don't want to go into that aspect. The point here is that there is a lot of mix of energies. Coal is still there, oil, gas still there, nuclear is still there. However, We have the new babies, the wind, actually they are not very new. They are increasing in their quantities. Wind and solar, particularly, let us focus on wind and solar. However, the problem with wind and solar is they are very random in nature. For example, solar is present only 5 to 6 hours in a day and it is random. Nobody knows. We need to measure. That is the first point. And then the total pool, any country, let us take India, the energy, the total pool is a mix of different energies and all that. Nobody, it is very difficult to, unless you have tools and infrastructure to measure and analyze and to provide visualizations, it is very difficult to understand the graphs like these and all that. The ones that you are seeing, they look very nice once they are drawn, but a lot of technology, somebody needs to measure, somebody needs to analyze, compute, and present in the graphical form and all that. That is the challenge, and probably that is about this lecture and all. So this, on the energy production side, we have so many different locations, different types of energies. They are random, continuously varying and all that. And renewable energies injection is very common. This slide basically shows the composition of the energies. Consumers are becoming prosumers. Prosumers means there are also some of the consumers are producers also. For example, let us say you have a big home and you can actually put up a solar PV system. Though it is very small, once it is put up, your consumption goes down. If a town of, let us say, 1 million people, 10% or 20%, they add capacity on their own, the total demand goes down. This is a loss to the state utilities, the government utilities or private utilities. And now a part of energy is produced by the consumers. So such consumers are called prosumers. So who is producing how much? Who has to pay for what? So that becomes a little complex, and cost of renewables is going down, and so the random nature of the mix will increase and all that. Modern energy pools are in combination, and this is the energy. Customer behavior, consumer behavior is simply unknown and continuously varying. Now let us look at a kind of a substation side and all that, a feeder. We take a simple feeder here, as you see. This is very important. A home is considered here. You have the solar PV and some batteries. This is what every house is having and all that. And if you see, some people can use even solar water heater, and this also brings down the energy consumption and all. This is the prosumer. A small feeder will have these houses. It is very common. And the intention of this diagram is this happens at the feeder level. Nobody will really tell about this. We hear lectures and we see papers and all that. The most of the activity is happening at the feeder level, because at the consumer level, and that is where we need a lot of. And you see here we have a modem and we have some visualization and all that. At the feeder level, the management is required. That management is called demand side management. This is what you see. So the same thing, and this is now this slide says basically varying generation and varying consumer behavior, and these are the daily load kind of graphs they look like and all that. Now, interesting point here is for all of you where the complexity starts. Data is collected for every 30 minutes. Actually, in most countries, it is now 15 minutes, which means every consumer will pump data, either producing and consuming, in some cases both. They every 15 to 30 minutes, depending upon the sampling rate and all that, they pump, and this data grows phenomenally. And what we call demand side, to manage this complexity, we use demand side management. And this is what actually on the load side, we talked about generation. On the load side, basically it is varying, everybody knows, and during the midday it will peak, and this is the peak load and all that. However, we want to know This type of visuals are required for computer professionals and computer science professionals and all that. Interestingly, this will be these visualizations are most required by the layman because they also want to see the things and all that. And now on the generation side, it is interesting. It is very important. Why this situation gets complicated is that if you see the load consumption is not constant throughout the day. It is actually starting slowly in the morning, and during the midday it goes to peak and then again goes down. That means the energy production also needs to be adjusted according to this consumer. If you do not sell a product what the customer needs, when the customer needs, in the quantity customer expects, there are three things. I repeat, customer behavior is very important here. When the customer wants, if you provide a lot of power during the night, the customers may be sleeping, they don't want, unless it is a factory or something. Then customer wants power, but there is little power and there are many and you have little generation and all that, and that is quantity is a problem. And where the customer location during the time of the day, these are, so we need to adjust generation also. Somebody needs to follow the customer. So the modern concept is we need to have power plants that have the ability to follow the load, what we call load following power plants and all that. How do we adjust? How do we measure? Who will tell? Unless you have a very strong IoT infrastructure and the data that can be processed from the sensoring, let us say you are sampling the data at the measurement level, you need to have a particular sampling frequency. When it is transmitted, when it is computed, when it is analyzed, that is a sensorization part and all. Now, we have seen the loads, we have seen the generations, now the tariffs. Tariffs are completely, it is a big area. Lot of softwares are being written even now. In India, there are many companies. Infosys is one of the major players. Infotech, I Square. There are so many companies that are, even the company that I worked in Delhi and Hyderabad, we had a lot of contracts from Uttar Pradesh to Tamil Nadu. We had a lot of contracts for developing billing software, what we call CRM, customer relation management and all that. You can find my papers. So time of use, because every 30 minutes data collected and time of use tariffs are there. I will just show you about that. And we need a lot of verification and measurement. Otherwise, customers will argue. You know, during COVID time, people argued with bills and all that. That's a big problem. People want to verify, and the boards have responsibility to measure properly. The meters are changing. Meters are now smart meters, prepaid meters, so many things. And data analysis, data aggregation is a huge. It is actually given to private contractors everywhere. And it is energy mix. And now the big push is that if you see the present government in India and in America, even in Australia, they are pushing towards circular economy. Some of the states in India are actually adopting the principles of circular economy in the energy sector in a way and all, which means this will add to the tariff. So in a nutshell, what is Energy 4.0 is generations are random and varying, loads are random and varying, different tariffs over the time. And to give you an idea, we measured here, Namibia doesn't have that much, India operates in terawatts and all that. Gone are the days, megawatts, kilowatts, megawatts, even gigawatts. India has surpassed everything. Just open Wikipedia page and see the demand and generation in India. It is teras in energy engineering. And the data that is developed by a small feeder means even probably a kind of university campus will generate a data. This is not power. This is not electrical power. This is the data. 350. What is P stands for? It is petabytes. It is not terabytes. It is petabytes. 350 petabytes of data is generated. If you want to do in MS Excel or MySQL and all that, that will not work and all that. And this is the energy 4.0, and we use demand side management to manage this. So why we need demand side management is that to better understand varying load patterns, better manage the data so that effective steps can be taken to match the generation to the demand, because we need to follow the demand. To do this, we need to handle the data, we need to sense with IoT sensors and then collect and all that. Earlier it was done by SCADA, real-time SCADA, and PLC technologies and all that, combination of complex analog technologies and all that. Real-time processing was done only in what is called, what they are called dispatch center. Since you guys are from Madhya Pradesh, you should know the regional dispatch center, one of the largest, the first and the largest regional dispatch center of India is located in Bhopal. It is the most modern now. Recently, it has been completely refurbished, and I wish I can visit again. I worked in Bhopal dispatch center, and all. So it used to be done in one place, but now those days are gone. Technologies have changed. Industry 4.0 has come into picture and all that. So the broad definition is basically why we need to deal with DSM. This is a broad vision. I don't want to read much about. It is the responsibility of the universities to educate people in actually about DSM and all that. Recently, I published a paper, with our local energy institute. We are actually deploying a kind of a DSM enterprise management system here in Namibia. So it starts with a typical substation. We will have consumers, lot of processing, databases, network information will be there. There will be a range of servers for different purposes and all that, and we have the client machines and all that. What you see is only a prototype. You can see virtual private cloud. We have commissioned virtual private cloud for prototyping the total system and all that. So what you see is only a functional prototype EMS. It is just about completed now. It is functioning. And this is about my in a book chapter. Actually, this is a book chapter that I wrote. And this slide, if you see energy management, this is from the Wikipedia page. It is the core business of a university. So every university must do in electrical engineering, in computer engineering, in electronics engineering, all the three, because it is an interdisciplinary area at the end and all that. So this is what it is now. I just want to, before we go into the demo and all that, this is what we have. This is being done after I joined this university. What I did is that I asked the regulator, ECB is the regulator, the Electricity Commission Board. So they have handed over the responsibility of demand side management to our university. And the official here is my colleague. She's from Namibia Energy Institute and all that. So it is the responsibility is handed over to university, and I am the actual person who is doing this. So now these are the visualizations. I don't want to talk much. We have seen the complexity. Now these are the visualizations required. I don't want to go into the names and all that, but for computer engineers, for programmers, for analysts, even mathematicians and all that, this is how the load is varying, and we need to adjust these curves and all that. First of all, the visualizations, we have some data, we need to have these visualizations, and these are six classical definition, by classical definition and all that. We have six possibilities. All the six possibilities look almost like this, and we need to have a proper visualization strategy for that. So we are coming into know kind of programming and implementation and all. What goes into DSM? IoT and sensor networks, big data, edge, fog computing, and data. These are the things. Now, please tell me, audience, please tell me, you are seeing four aspects. It is just computer engineering. There is nothing really electrical engineering here. The quantity that we handle is the commodity is energy. That is basically probably physics or electrical or whatever you can call and all that. But these are the activities that go into demand side management and all that. Now we take up one by one. Let us look at the data. To give you a simple kind of data and computation, I don't explain this. This is a keynote speech. So if you see time of the day, 0, 1, this data to save our time and all that, I have incorporated every 1 hour interval. This is up to 11 here, and then starts 12, 13, 14, goes up to 23 and all that. And this is in load in kilowatts, but there will be another load called kVAR. This is active power, and the other one is reactive power, which means part of the load is not shown. And this is not the complete load either, because we have to present the data for every 15 or 30 minutes and all that. So this is a kind of summarizing. The data is looking like this, and there is some calculation here and all that. And people want to see before and after. I don't want to go into the details, but when you calculate, the results look like these and all that. So the computation should present, the programs should be written in such a way that they present the results before and after. So which means it's just not the graphs. You need to have some display of numbers and all that, and before and after. My question is, for how many people, how many points, how many locations we are going to do this? That is the interesting question. These figures are different from consumer to consumer. Every consumer you need to show. Every factory, every household, you have to show these things the moment they adjust for certain strategies that we bring in, and every consumer will adjust, whether it is a shop, whether it is an industry or factory, whether it is a municipal load, or even a public park, airport. Everybody needs this data before and after, how much they are paying in a year, how much they are paying in a month, whatnot, and all that. This is only a small portion of what you're seeing and all that. And there are lots of questions. And if I ask you how to plan energy demands of a small township that has average load of 800 megawatts. 800 megawatts, let us say in Bhopal and all that, it is a small township, given the scale of Bhopal, for example. And the interesting thing is that these days, the budgets, the planning, everything, they're not really looking into energy aspect, they're looking into ICT infrastructure. If you don't have those ICT infrastructure, there is no audit that is possible. Nobody knows where the energy is going, whether energy is there and it is not utilized. If it is not utilized, we are not going to get revenues. If it is utilized, and if there is no metering system and all that, then we will have problem. So the first thing these days, everywhere, even in India, people are looking at the first and foremost thing is ICT infrastructure, from sensing to the visualization. If that part is not completed, we can't even think of putting up a substation and all that. So a lot of background ICT work goes on, even in the design and all that. Planning. This is the question is about planning and all that. So once again, I am telling you the generation. This is the generation, and this is the visualization on the load side and all. So these are the questions. Do these one consumer or gated community? I have already asked this question. How many load curves we need to generate? I can only say the number can exceed even anybody's imagination and all that. What is the criteria? How to display? At what speed we can display? This is really huge. And is there any process? Is there any system? That is what we are trying to do and all that. So this will provide a kind of full runaround project for any student or any researcher or any even professors, anyone want to do certain things on their control. They don't need to really know energy engineering really. There is a significant interest, blah, blah, blah. This one, recently I presented this in Florida. So some of the slides from IEEE Florida, they are here. And now, I want to show the curves directly. This is the daily load curve. This is what the books show. But the utility engineers want to see like this. This is interesting. These two are same. What you see, this is very important. Especially if you are in from computer science engineering, you will know the visualizations, they may appear totally different, but they may be same. Now this one is drawn from 01 to 23 hours, what you see. We will have a little demo here. And then the load duration, it is the same. How it is drawn is that the load is varying here. And here, what we see, let us say in this, the minimum load is this, about 75 or so and all that. So that is called base load. That base load is there for 24 hours. So we would like to have that number here as a straight line and all that. And rest of the times and all that, the load is high, but for existing for small place. If you take this slice, small size, and this load is about 350 megawatts is not existing 24 hours. It is existing for few hours. So if you see here, if you translate from here to here, 350 megawatts is existing only for 2 hours. Now, audience, delegates and professors, this is what we need to display this, and we also need to display this as well. So there needs to be computation within the visualizations and all that. This is a requirement. And these are some of the, we need kind of, some of the visualizations. We need to display different things and superimpose and all that. And load growths and numbers. And let me kind of go to my screen here, my demo, and let me do a little demo so that you will understand what is basically this one and all that. So I am opening up. I just want somebody, if they can tell me if they can see my, because since I am not able to hear, can anybody type if they can see my Excel sheet on the screen? Can anybody see my Excel sheet? I hope you are able to see my Excel sheet. Okay, so here, this is what we are able to, okay, this is what I just want to demonstrate. There is a data, and this should be done on a typically on internet and from a cloud. What I am showing is from Excel, because this is a prototype for the prototype that we designed. Please don't get me wrong here. In the prototype, the recent development is that we are using rapid prototype development model, Scrum, and also kind of prototype to prototype. So this is in MS Excel to explain to the developers. Here I developed myself to explain the students and employees so that, hey, look, this is how your visualization should be. So they can delete, they can use this one. This is also published, and this is due to appear in IEEE conference, one of the publications. So this is how it is. Let's not go into the, this is very straightforward. And if you want the same thing, now the load duration plot comes here and all that. So they will do the calculations and all that. Now here, this is called what we call, this is a base plant, same load, but since during midday, it is too much energy and all that. Usually networks are stressed with heat. The engineers need to clip the peak. So what we say, we will look into prospects, into the data. Everything is from data, and we want to remove some of the load and all that. So when I simulate that peak shave load, if you subtract from this, you can, I will explain. If you subtract a constant, in this case it is 100. You see 100. If you subtract 100 from the top, the result will be like this. Let me put it 300. And you will see, look at this. So I subtracted too much, it even went into negative and all that. If I put only 50 here, okay, what I have done here, am I kind of boasting and explaining the MS Excel here? No, not really. Engineers, before they want to clip, they want to remove some load, they want to have some tool over the internet so that they can experiment different values and then take the action, switching action, which is clipping a circuit breaker, removing some feeders and all that. This is important. So they need a simulation tool, a computer tool with visualization, with the data manipulation, so that they can construct 3-4 scenarios and compute the cost. That is very, very important, because you can't really take some random action and all that. They need a quick tool that kind of simulates all these things and all that. However, delegates, it is not how it is looking and all that. The textbooks, they will be showing a nice picture. Let me show this. Textbooks, so a smooth graph. This will not happen. If you are looking at textbooks and research papers, this is how it will be displayed, but that is not true. In reality, it will be like this and all that. Anyway, let us go into solar PV thermal. Now, you see here, there are some calculations here already. Kind of how much it is shifted and all that. The problem is utility will lose a lot of revenue when customers install solar PV panels and all that. But you know, that is a loss to the utility, gain to the customer, and we can't stop, but we need to simulate them and all that. So we can add solar PV in this. Solar thermal also we can add. Solar PV plus thermal also we can add. And so these tools are required, and this is a good master's level project. Actually, what you're seeing, valley filling, load growth, these are all the load growth and all. So I wouldn't be taking, and now energy mix also, let me explain how it is done on the energy mix side. And let us say there is a base load plant, and we need to simulate kind of few feeders. Let us say a university has gone, I'm sure number of universities in Madhya Pradesh may have added, as per the central directive, a lot of solar PV capacity and all that. And that is a loss for the utility, state utility. Let us simulate that condition and all that. And let us say this is the kind of crude, vague simulation. Now we have a base load plant here, and solar PV plant is there. And if you mix both of them mathematically, this is how it looks. If you add this and this is what it is and all that. But you know why this is not something. This looks very baby demonstration. However, what you need to do is that you need to have a simulation where you can change the data, and start hour, end hour, you can put, and peak hour you can put, and peak hour, everything you can change with the simulation. This tool is, this type of tool is not there. It is very difficult to do, and all that is what is my contribution in this lecture and all that. Now, let us go ahead with the presentation. I hope. So these are the things that we have seen already from the demonstration. So demo 1 we have just completed. Now in reality, infrastructure wise, really, let me put the reality to you. It is too many databases, regulatory aspects and conditions and all that. I challenge, actually I encourage, my apologies, it's not challenge. I encourage everybody to think and implement in a laboratory. Let us say you want to implement in your department in a baby scale and all that. You will come across all these things in a way or other, and then you will realize the complexity and all that. This is how it looks, a complex diagram. This is not mine. This is from IBM actually, but more or less they will be there. Now, is it that bad? Can we develop in laboratory or not? That is the point, because you're all in academia. Let us see how it works and all that. So once again, this is too complex and all that. Don't worry about the complex. It is very easy. I will just provide the solution to you also to complete the kind of. IoT, everybody knows. You all know IoT. I don't want to discuss IoT. And why you need to do this is that how to teach. Let us say you want to develop a small thing to teach your students, or probably teach yourself, and how to train engineers and all that, how to design and develop a simulator, how to compute. That is what the challenge is and all that. With IoT and big data, it is possible to develop low-cost systems in a laboratory setting, in any, even in a smallest college. It is happily people can develop and all that. It is possible. I have developed one. I will show you. This is what KL University. I was visiting a professor in KL University in India, in Andhra Pradesh, in Vijayawada. So you see the laboratory and all that. They have a very small lab and all that, but still we are able to. So what you see here is the lights, the regular lights we used as bulbs and all that. And I put up a modem and Arduino and all that. You can see. I don't want to go into the details. It is pretty straightforward. Basically, you can simulate loads with these things, and measuring and all that can be done with this. Communication technologies can be the network infrastructure and VPC can be done with a kind of mediocre, low-end, cheap modem. And we have developed, we have actually demonstrated this to a conference that we conducted. You can see people actually using their mobile phones to control everything and all that. Now, let me go back to the pictures. This is some hardware. These are people. Where are the visualizations? That is why. Where are the computers? That is what is important. I think I don't have here. Let us see. And this is the conference that we kind of conducted and all that. Yeah, this is the visualization. Thanks. We have boys. Actually, we put up sensors, IoT sensors in boys' hostel, girls' hostel, staff apartments, bank, library, everywhere we put up because IoT equipment is very cheap. And we have this status, and students have done. I involved students and all that. And in 2016, this is the visualization and all that. Other visualizations you have seen already and all that. These are this you can implement on single phase power also. This is done in Namibia here, and these are some of the kind of visuals. There are many different ways, many components, so you suit yourself and all that. If anybody wants details, please feel free to contact me and all that. But recently we developed, our prototype is visited by Jalal, one of, he is economist, well-regarded economist. He is the chief of, actually he is promoted now. I am actually working with him on ADB. This is African Development Bank. He came and he saw our prototype and he was impressed. So he asked me to come onto the board, development board and all that. We did, and now he has given us grants to further develop, and he is actually chasing all of us and all that. So we developed, you can see me smiling, and you can see the demonstration and all that. You can control with mobile phone, you can control with your computer, whatnot and all that. There are lots of prospects. All this is made possible with IoT Industry 4.0 revolution and all that. So they were pleasantly surprised and all that. You can have, these are some of the visualizations on mobile phone and all that. So data visualization, to go into details, current, voltage, active power, reactive power, and power factor in real time. And this is what is being done by SCADA nowadays and all that. You need to get this into IoT side, into the laboratory setting without investing any money and all that. The programming, you need at least 4 or 5 projects, 4 or 5 serious projects. At least you can keep about 30 students busy in this segment and all that to get it perfected over 2 years and all that. That is what I'm just giving you a kind of planning in time also and all that. And if you want to perfect, you can use other technologies. This is some of, you can do these visualizations. Don't get scared and all that. Easy to do these things. Many of you may have already done probably and all. This is Microsoft Power BI. If you don't want to program, quickly you want to put up the system within 2 months and all that, you can use Power BI for visualizations. It is very good. You can use it with many different technologies. So these are some of the visualizations that I developed. I'm a consultant. I'm not really a academician completely. I have more than 32 years of experience, 30 plus years of experience in since I graduated my BTech. It is a long journey from NIT Warangal to Namibia. I have consulted in different countries and all that. So this is one of the works we have done in Trinidad. This is how power engineers expect the visualizations and all that. So this is how you guys need to program. What these things are, these are different generating stations, and these are actually previous loads, the kind of 1 hour, 2 hour, 3 hour before loads. And this is the current load. This is the current measured load by the IoT system. That is what. And these are predicted. So forecasting, you need to write algorithms using ANN or machine learning. Well, we are coming to that area now, research opportunities. You need to use those algorithms to predict this part and all that, and then compute, and then use data visualizations to display this. And there is no electrical engineering here, really. I'm sorry, being an electrical engineer, but this is what the current market is, current world is. If an engineer, a student is not able to appreciate that, then it will be a serious issue with job prospects and all that. Please understand the requirements of modern world. It is all about programming, ICT, and big data and whatnot. And there are so many areas and all that. So some of the algorithms that minimum R&D opportunities are existing, but minimum focus for researchers and even undergraduate students should be in this area. I don't want to teach them K-means. We have implemented all these things, decision tree, logistic regression, and NB classifiers, random forest, there are so many are there and all that. And this is the conclusion. It is the area actually, IoT, cloud computing, big data, digital twins. We are at the verge of completing our first digital twin, and my paper will appear very soon. And cyber computing and security, especially far behind cyber security, and mobile computing, especially mobile computing, another big area and all that. So this is what my lecture is and all that. And unfortunately, I'm not able to hear any of you guys. And that is what my lecture is and all that. Thank you all. Sorry, there is a kind of morning sun here. My sincere thanks to everyone, especially Professor Tomar sir, who has given me abundant, unlimited opportunities in consulting opportunities across the globe. He's really a great inspirer for me. He's my mentor. He's from the land of Madhya Pradesh. I know that.
So, thank you, Doctor.
I'm sorry, I'm still not able to hear anything from you. I do not know if my presentation is audible, visible to everybody.
Yeah, it was a very excellent presentation, but unfortunately, our sound is not going
Can I
to
stop?
work. One-way it was a one-way communication, but we enjoyed your presentation, Professor. And thank you very much, Dr. Bandana. Please continue, Dr. Bandana, Dr. Lakshmi.
Hello. I'm not able to hear anything. I am able to see only the chart.
Yeah, good morning all. This is Dr. Lakshmi Kumre. I hope everyone is,
Thank you very much.
Am I audible to all?
Leeladhar, Professor Leeladhar Malaviya, sir. Thank you. Thank you, sir.
Thank you so much, sir. Thank you so much, sir.
Dr. Lakshmi, please continue.
Yeah, yes, sir. Yes, sir. Okay. So, on behalf of this national conference team, I welcome you all guests and participants of this link. And now, second session, second part, that is the technical sessions. So, I welcome you all again in this technical session. And along with me, I am the session chair of this technical session, and along with me, Dr. Dr. Bhavna from the MANET is also a session chair. And first of all, I would like to call. I hope this session schedule is shared in WhatsApp, and every participants know about this. So, in this technical presentation, first participants is Dr. Abhiruchi Pasi. So, is she available?
Savarkar sir, Savarkar sir. Thank you, sir. Ajay sir. Thank you.
Abhiruchi Pasi.
Hello, ma'am. Good morning.
Yeah, Dr. Abhiruchi, you are the first participant.
Ma'am, this is my student's paper. So I'm just trying to contact him. Is it possible to reschedule
I'm not too sure if I'm on time or not, but I completed my presentation.
Okay, Dr. Yeah, Abhir, okay. So, okay, we'll consider. So, next participants is Ikara Gupta.
Thank you, ma'am.
Thank you, Singhal sir.
Yeah, ma'am. We are presenting the screen now.
So you are ready with the presentation?
Yes, ma'am.
So kindly share your screen.
Sure, ma'am.
Thank you, sir. Thank you very much.
Shall I start, ma'am?
Yeah,
Ma'am?
yeah. First,
Good morning, everybody.
Yes.
Today,
Lakshmi ji,
I'm
thank you.
Muskan Kapahi.
I, Kagru Gupta.
I request all participants to please mute yourself.
Good morning, everybody. Today, I'm Muskan Kapahi.
I, Kagru Gupta.
Will be presenting our SIW structured antenna for the application of RF and millimeter technology under the roof of this two-day conference NCN GCT 2020.
Our topic is SIW structured antenna for the application of RF and millimeter technology. We will be introducing a novel design SIW antenna and various needs for RF and its various applications in RF and millimeter technology.
The presentation overview will be like this. We will be first introducing what is RF and what are actually RF and MM waves, what is the frequency spectrum in which the potential RF and MM waves, why do we need them, was the existing communication system not enough or not up to the mark?
Yeah, it's design
Then we
description
have
in
designed, then we have explained.
Yeah, it's design description in planar and conformal configurations with the simulated designs. On the top of that, we need
Mr. Gupta and Mr. Gupta and Muskan, I request you to speak one at a time, and for 50% time you speak and then give over to next person, because we have allocated only 15 minutes time to you. If you speak one line, then it will be very difficult to accommodate.
Yes, sir, we have taken your important suggestion into consideration, sir. It was just till this slide. We will be discussing, the Ekagra will be covering the technical part and I will be covering why we have chosen this field. So we have distributed the
Yeah, Muskan, start.
So millimeter wave technology operate in the range of 30 to 300 gigahertz and have a very promising future. They operate in the current unlicensed frequency bandwidth of 60 gigahertz, and this bandwidth, unlicensed bandwidth, actually ranges from 57 gigahertz to 66 gigahertz. These RF and millimeter wave technology have not been a latest invention. They have existed for quite some time now, and they were traditionally used to fulfill the requirements of transmission of data indoors and for short-ranged communication. Because they were used in short-range communication, they promoted a secure connection. Now they have a very have been operating in the this is a overview of the technology which we have been using for the microwave communications. Ekagra, can you please go to the previous slide? Thank you so much. These were conventionally used to fulfill the requirements of the data indoors. Now, why we have chosen RF MM waves is because of the improved, increased data traffic, which has been predicted. There is the need to tap into the potential of new frequency spectrums which are yet unused. So the RF and MM waves supply a bandwidth of approximately 2 gigahertz, which is much larger than what is being currently used in the 4G networks. Next slide. This is the existing technology which we have been utilizing with the communication, with the existing communication networks. The GSM mobile phones and the ovens were operating the microwave communication range. The satellite communication then shifted to the 20 gigahertz range, and now the millimeter communication will be, we will be expanding to even further into the frequency spectrum. What was the need for the RF MM waves? In India, it has been noticed that the data traffic has been increasing exponentially. Moreover, because of the 4G networks, a boost was seen in this field. Now, only 4% of the Indian households have a dedicated broadband networks, and so the smartphones which are enabled with the cheap data plans which we get nowadays are the only source to gain access to the internet. So all these have contributed to the exponential increased data traffic. Next. The RF and millimeter technology, which operates in 30 to 300 gigahertz, is able to provide a high dimensional multiple input and multiple output operations, and it supports the reuse of the frequency spectrum at small distances when operations and when incorporated with a large antenna array. Improved features in the as we have seen that they have a higher bandwidth, and they will be able to provide a bandwidth which is much larger than what is being currently used. So they are being used, they are being seen as the future of the cellular networks. The millimeter wave technology utilizes the it's seen as the future of the outdoor cellular system, because by incorporating the usage of multiple antennas all operating in the same space, this can be achieved.
Yeah, thank you, Muskan. And we come over to the novel design. The on the left hand side, I have this the top view, the patch, and the substrate sandwich between the ground plane and the patch. The material, the metal material of ground plate and top plate is the same. And as we can see, I have taken a rectangular patch with the metallic wires, which is the main key property of SIW antenna. The two congruent triangles on both the sides, which are isosceles in nature, have been placed with four identical circular with four radii of identical radius are there, and this makes the bandwidth much more higher than it is expected to be. So this is the planar configuration, and coming over to the design, these are return loss and gain curves. As you can see, return loss came out to be at 55.87 gigahertz, which is its operating frequency, which comes in the range of 5G communication, and the impedance mismatch bandwidth is 1.84 gigahertz. The gain, however, came out to be overall gain achieved equals to 8.36 dBi. Shockingly, when we converted it to a conformal configuration with the radii of curvature of 7.7 millimeter, the return loss and gain overall gain increased by about 1.5. Yeah, so as we can see, return loss came out to be 2.79 gigahertz, which is nearly 1 gigahertz higher than the planar configuration, and also the overall gain equals to 9.585 dBi. Both of these, the conformal and planar configuration results are being taken care with respect to the operating frequency of 55.87 gigahertz. The radiation patterns are as follows at phi equals to 0 degree. For both, on the left hand side, we can see the radiation pattern of planar configuration and SIW antenna, and on the right hand side, we can see as a labeled B part, radiation pattern of conformal antenna. The main advantage, if we talk about SIW antenna, is the reduction in fabrication cost. As we have came so far in antenna technology, like we need to increase our frequency spectrum range. So to construct a microstrip patch antenna with such discrete and detailed design, it conventionally increases the manufacturing cost. So by not increasing the complexity of the design, we have designed one SIW antenna which merely increases the cost and keeps it as low as possible. The other advantage is high density integration. Since if the antenna design is too complex, we cannot mount very discrete components on it. But as the design becomes simpler, we can mount different designs, we can achieve circular polarization more easily, as we can say. So these things are to be taken care of. Muskan?
Yeah, thank you, Ekakra. So what our antenna has done in this field of increased communication, as we all know that the data traffic has been increasing. So this growing need has drawn our attention to the existing but underutilized frequency spectrum of the radio frequency millimeter wave. This spectrum has a good range and has been used conventionally in the short range communication systems, and it provides a good bandwidth. Now, because the 5G came into existence, the further need for tapping into the potential of new frequency spectrums arose, because we cannot be operating in the frequency spectrums which are being previously used. Thus, RF and MM, thus making RF and MM waves as the perfect solution for the frequency spectrum of our antenna. Finally, concluding with what our antenna has done in this field, it is a novel design structure which will be able to provide bandwidth in the most impactful way to meet the ever increasing demands in the cellular network communication. Moreover, as the number of available frequency spectrums reduce, the RF and MM waves are just the perfect solution to the foreseen data traffic demands of the 5G network. In this paper, we have presented a novel, simple and compact surface integrated waveguide transmission based antenna. We believe that our initial simulation results provide worthy insights into the understanding regarding the usage of high frequency spectrum as the future of the cellular networks. Thank you so much.
Thank you so much for your time.
Thank you, Ekagr. Thank you, Muskan. I request audience, if they have any query, they can ask.
Hello.
Yes, sir.
I would like to know whether the SIW technology what you have presented is usable in 5G.
Yes, sir. It is usable in 5G. 5G. It is made in an impression to be used in 5G. Like 5G ranges from 24 gigahertz and it goes up as high as possible to around 100 gigahertz. The operating frequency of our antenna is about 55.87 gigahertz, which surely comes in this range as mentioned.
My last curious question is, suppose if you are given a choice of GCPW and SIW, which is better for 5G?
Yeah, sir, I'm so sorry. I have no knowledge about GCPW,
Okay.
but
That is
I'm
ground supported CPW.
Sorry, sir.
Ground supported CPW.
Yeah, ground supported CPW, sir.
Okay. Thank you.
Frankly speaking, I might not be able to answer it right now because without having any knowledge, it will not be fair. Yeah, thank you so much, sir.
Any other participant? So if there is no query, can we move to the next paper? Okay, so according to the list of schedule, the next paper ID is ID 03. The topic of that paper is analysis of microstrip patch antenna, a review by Mr. Rachit Jain. So Mr. Rachit Jain, are you available? Are you ready with the presentation? Mr. Rajit Jain.
Hello, am I audible?
Yeah, Rajit.
Ma'am,
You are audible. Are you ready with the
ma'am,
presentation?
paper is presented by Miss Ashni Tiwari here.
So Ashi Tiwari is available here?
Yes, ma'am, he's here. She's here. And maybe she...
Ashi Tiwari, can you share your PPT? Rajit, please coordinate with Ashi and please tell her to share presentation because your name is written in this list.
All right, ma'am. Okay, just a minute, ma'am. Okay.
She is in meeting?
Yes, ma'am, she is there. Maybe there is some technical issue. I'm coordinating with her.
And for other participants also, I am just reading the list. So after Rachit Jain, next paper ID is paper ID 4. That is title is a CPW fed cup shaped UWB antenna for the application of next generation communication system by Mr. Tarun Agrawal. So Mr. Tarun Agrawal, are you available in meeting? Tarun Agrawal? After Tarun paper ID 5, next one is assessment of state-of-the-art digital forensic techniques by Ms. Shushma Jaiswal.
Instead of her, I will be present the paper. My name is Tarun Jaiswal, ma'am.
Arun Jaiswal.
Tarun, ma'am.
Tarun, so you are going to present paper ID 5.
Yeah, ma'am. I will be present the paper ID 5, ma'am.
Okay, so if Tarun Agrawal is not available, so we can start your. Please be ready with your presentation.
Okay, ma'am. Okay.
Okay, so Mr. Rajit Jain.
Ma'am, there is some technical issue.
Yeah,
Yes, she's
Ashni is
right. She's
also.
right now.
It's easy. Travel.
Yeah, Ashni, can you hear PPT?
Yes, ma'am. Yes, ma'am. In a
Yeah,
second.
please share and start your presentation. So time for presentation is 10 minutes and 5 minutes for query.
Okay, ma'am.
அந்த இது வாங்கிட்டு தரேன் அந்த இது மாத்திரம் கூட ஆதார் கார்டு ரேஷன் கார்டு அந்த மாத்திரம் பண்ணி வாங்கிக்கலாம்
Mr. Raghavan, can you mute yourself?
இல்ல அதெல்லாம் கொண்டு போய் ஒரிஜினல் காமிக்கணும்
Ma'am, shall I start?
All participants presenter, please mute yourself. Yeah, Ashni, you can start your presentation.
Okay. Good afternoon, everyone. I am Ashni Tiwari, EC third year student of ITM Gwalior. I will be presenting a paper on analysis of microchip type antennas using ANN or review. And my co-authors are Mr. Rachit Jain and Ms. Ayushi Chauhan. In this, I will be including overview of microchip antennas, justification for present work, artificial neural network, analysis of paper, inferences drawn out of literature review, future scope of the work, and references. So starting with the overview of microchip patch antennas, it is one of the most useful antennas at microwave frequency, which is greater than 1 gigahertz. And it usually consists of a metal patch on the top of a grounded dielectric surface. And the patch have many varieties, but what is the most common is rectangular and circular. So these are the advantages of microchip antennas. It is easy to fabricate, easy to feed, easy to incorporate with other microchip elements. And
You are not sharing your screen.
no, ma'am, I am sharing my screen.
It is not visible to me.
Wait a second.
Bhavna, it is visible to us. You are not able to see?
Yes, ma'am.
So check. Actually, it is visible to me.
Okay. I will see again. Ashin, you will share with some other name?
No, ma'am.
The same Ashin name. Okay, I will log in it again. Yeah, you will continue.
என்ன
Other than presenter, I request all participants to mute yourself.
Ashni, you will continue.
Okay, ma'am. Okay. So where I've left, yes, easy to, and it is easy to incorporate with other microchip circuit elements, and also it is easy to integrate into the systems. And the patterns are mostly of hemisphere shape, and the directivity is around 6 to 8 dB. And also it is used in array to increase the directivity. So justification for the present work. Antennas are, as we all know, that is a very complex problem, and it is used in spacecraft, aircraft, missiles, and the antenna which are required is of small size, small weight, cost efficient, and of course easy to install. Mobile radio and others wireless communication demands such specific antennas. So to fulfill such requirements, it is required microchip patch antennas, but for designing of antennas it takes a lot of time, and so to reduce the time and to get the optimized parameters, we have analyzed the ANN model, artificial neural network. So it is a piece of a computing system designed to simulate the way our human mind analyze and process the information. Here the ANN model is a system with input vector S dash representing the circuit design parameters, which are height of the substrate, dielectric constants, cutoff frequencies, which are F1 and F2. And the output vector are just representing the patch dimensions, that are length of the patch and width of the patch. This is the block diagram of the working of So from the input layer, we provide the inputs parameters, which are length, breadth, dielectric constants, and then it goes to the hidden layer, where it performs the hidden trial methods like recognize, and then it is goes to the outer layer, which is the final layer. And along with this, we also feed the target values from any simulator, as we say IE3D, CST simulator, or HFSS, and at the final we get the final ANN frequency. So we have analyzed different papers. Investigated the multi-slot hole coupled microchip antenna with multiple frequency characteristics to achieve wide bandwidth. And he also used the ANN to calculate the radiation patterns. And in this, he suggested the use of genetic algorithm GA to fix the initial weights of the multilayer network for the faster coverage by coupling the GA with ANN to select the initial weights. And in the comparison at the last, it shows that GA techniques provide the accurate result for resonant frequency, and recognize frequency very easily and in less computation time. So the second paper is by Mr. Patnaik. He proposed a work for locating the faults in the antenna array using artificial neural network. And in this, he said when the antenna is used in communication system, many radiating elements are required, and there is probability that one or more than radiating elements may be failed. So this failure results in distortion in the patterns and also destroy the symmetry. So at last, the methodology is tested for linear array as well as for planar array to provide the results which provide good agreement with simulated results. This is a paper 4. Mr. Mishra investigated that circular patch antenna prototype for experimentation was found to be very difficult. So he used ANN to develop the parameters. And also he used the conjugate gradient backpropagation algorithm for a synthesis work. And he said that neural model provide good correctness, and there is also no complex mathematical functions. And also AN model provide robust results when it is used for more data set, and the results which we have predicted was very efficient. So these are the inferences drawn out of our literature review. So the main advantage was of using the soft computing technique is to increase the robustness and also the performance of the antenna. Microchip antenna is used because of the small size, low profile, and operation at different frequencies. And optimization is used to design the antenna of small size, which provide quick response, performance constraints, and accuracy. And at last, the ANN model is used in which feed position and amount of iteration and are reserved as inputs and provide various parameters as output. These are the comparison table in which I have studied the different paper and compared the algorithm ANN with other algorithms and their outcomes. So the first antenna type is multi-slot hold couple antenna. In this, he has author has used the ANN and it is compared to GA, which the result is GA algorithm provides an accurate result for resonant frequency very easily and also in less computation time. And the second type is circular patch antenna. The algorithm was used was conventional simulations, and it is compared to ANN. And the output is ANN model provides good results for the large database and quite efficient also. This is the second. Third paper, and the antenna type is planar inverted F antenna. Use algorithm was SWN, and it is compared to MOM and ANN. And the outcome is ANN speed up the design process while maintaining the high accuracy level. Third, reflect antennas. The type of antennas were reflect arrays, and the use algorithm was cringing compared to conventional simulations, and the outcome is it saves the time up to 99%. And the second last is the antenna type slotted wave guide antenna. Use algorithm is ANN, and which is compared to conventional simulations. And the outcomes are computation of parameters with a well agreement with the simulates and use algorithm was Gaussian process ML, which is compared to differential evolution. And the outcome is it accelerates the design and reduces the step by 4 to 5 steps times compared with the differential method. So the future scope of work is we will be working on the MATLAB ANN toolbox to see the results and also how well it is optimizing. And also different analysis and synthesis and ANN model could be developed for the other performance parameter of microwave circuit like input impedance, directivity gain, BFWR, return losses, and etc. These are the references. Thank you.
Any query from the audience?
Hello. See, I got one small question. See, for a single patch antenna, which is better, conventional method of designing or ANN?
For a single patch, sir, I think conventional is good. But because with ANN, we actually reduce the time of designing the parameters. And
Please answer which is better, that's all. Conventional method or the ANN?
I think the conventional method is
One last question. See, you are told the back propagation method. How did you arrive at back propagation? Unless you compare all other things, one cannot come to back propagation. You have to compare. Did you do that comparison? That's what I want to know. Or directly went to
no.
back propagation?
Sir, actually, I did a study from different papers, and I found that back propagation algorithm is quite good because
Is it quite good or the best?
no, sir. I think it is a quite good, and I'm still learning on it. I'll be finding out what is the good.
Okay.
Ashni, you have done the simulation also in MATLAB, or you just compared, you have done the analysis part only?
Ma'am, I'm still doing the future work in MATLAB. So it is going side by side. But till now, I'm still learning and studying the papers and the review.
You are in which year?
Ma'am, in third year.
So this is your project also?
Yes, ma'am. It is my project also.
Okay, good luck.
Thank you,
And
ma'am.
it is very
Good
nice
luck, Lakshmi.
presentation. Thank you
Nice
so much.
presentation.
Thank you, ma'am. Thank you so much.
So now, next one is Mr. Tarun Agrawal. Paper ID 4, Mr. Tarun Agrawal.
Madam, can I talk to the chairperson of this paper presentation session?
Which one? This, yeah, I am a session chair. I am Dr. Lakshmi Kumble. Yeah, please.
Okay, madam, see, the simplest question, even all the first two persons did not answer. I would like to know how these papers were selected in this kind of a common podium. Or I request you to ask one simple question. Simply they are reading, that's all. The simplest question, even they are not answering. If it is that, I feel the selection of papers, simply whoever is applied got selected, I think. Anyway, I want you to make a note of it.
Yeah, Professor Raghavan, may I reply to your question with the permission of Dr. Lakshmi Kumare?
Yes, sir, please.
Yeah, you are
Don't get
absolutely
back.
right. See, the knowledge level is a relative term. We cannot expect everybody to be a very high level person. So we are here on this platform to encourage the young researchers and to all the researcher and put their ideas. And if the other researchers are finding the idea suitable, it's okay. And it, see, being teacher also, I have 35-year experience. I cannot always say that I will be able to answer 100% question. If I am not able to answer the question, at least I am able to learn something. And purpose of this platform is to learn from the presenters and to get knowledge, to educate them and get ourselves educated. This is the purpose. We are not here just to criticize anybody or where they are able to. I have also presented paper in number of places. I was not able to answer. Even at present in class, I am not able to answer to certain questions. It is not necessary that I should leave this job. Okay,
Okay, sir.
so this is
Okay,
my
sir.
submission.
If it is so, then it is okay. Okay, I'm sorry. I apologize.
Actually, please continue.
Yes, sir. Thank you so much, sir. So according to list, now I would like to call presenter of paper ID 4. So Mr. Tarun Agrawal, are you in link? Are you in meeting? Any other author of this paper ID 4? Okay, I think they are not here. So I would like to call the next paper. This paper ID 5, Assessment of State of Art Digital Forensic Techniques by Miss Sushma Jaiswal. So instead of Sushma, I think Tarun Jaiswal is going to present. Tarun, are you ready for with presentation?
Yeah, ma'am, I'm ready, ma'am.
Yeah, please share screen.
Yeah, ma'am. Ma'am, is it visible to all?
Yes, Arun, it is
Hello.
visible.
Yeah,
Yes, yes, it is visible. You can start.
Good morning to all the professor and my friend. I am Tarun Jaiswal, presenting the paper Assessment of the State of the Art Digital Forensic Technique. First of all, what is the forensic science? When we talk about the forensic science basically is the use of scientific method or the expertise to investigate the crime or examine the evidence that might be presented to prove the criminal in the court of law. Basically, the forensic science comprises a diverse area of discipline that might include the analysis of fingerprint and the analysis of the DNA. From DNA analysis to anthropology and wildlife forensic, they all come in the umbrella of the forensic science. And we can say that the forensic science is the uh, science that is used for to identify the criminal or to criminal, and after identifying those criminal to present those criminal in the court of law. Basically, forensic science is a applied science. And applied science, we can say other name of the forensic science is the criminalistic, and applied science is a branch. You can say it is the branch of science that applies the existing existing scientific knowledge to develop the more sophisticated the application. And according to the author Srivastava, the digital forensic is the process of analysis and evaluating the digital data as evidence, and it is the science of locating the evidence, then extracting the information from those evidence, and after extracting the information, we analyze those evidence from the different type of data from the different devices, which specialists are the investigator then interpret to the legal advisor. Yeah, basically, forensic process contain three steps. First one is the acquisition of the data. Then we come to the second phase. This one is the analysis of the data, and third one is the reporting of the data. In the acquisition of the data, we acquire or gather the various kind of data from the different sources, and after the acquisition of this data is basically is duplicated by the several means, so that the original data will not be destroyed in the future, and by any means, if the original data is mitigate or destroyed, then we have the duplicate data of the original one. And after acquisition of the data, the original drive is returned to the secure storage to prevent its tampering from the by the physical by the physical evidence or the by or some person. In various cases, the original evidence is tempered by the people that involved in those investigation. Then we come to the next stage of the analysis. After gathering of the data, we come to the next step, that is the analysis stage. In this analysis stage, we analysis the data which is gathered from the various stages, and during the analysis, basically investigator or the detective usually recover the evidence that is identified from the various material using by the different methodology or the by the different methodology, and that different methodology maybe the USB pen drive or the hard drive or some other recording of the CCTV camera. And after obtaining such information, it is very critical phase to analyze this data. Basically, in the analysis, we often identify the deleted data which is not presented in the original source. For the analysis purpose, various tools are available, such as a hash signature that identify the notable file, or and this hash signature produce the same type of information which is deleted by some known or unknown person, or it may be compared to the previous file which is available in the hard drive or the pen drive. Yeah, in the analysis phase, basically digital investigator, you can say the criminal investigator, ensure that that their analysis conclusion is based upon the data and their own expert knowledge. Now we come on the third phase, that is the reporting. Yeah, when after the acquisition of the data and analysis, the third most important phase is the reporting. When after we have completed the analysis part of the data, it is very important to produce the outcome of that analysis information in the form of report, and this information in the form of report as an outcome is the proof that some person has committed the crime. And basically this report may be in the form of technical and in the form of non-technical. When we talk about in the non-technical report, this non-technical report may be the simply the comparison table or the graph that may be printed on the paper, and we compare those non-technical report with the technical one, so that we can easily identify what kind of outcome we have get from the analysis of the data. Basically, we can say for a criminal report, this non-technical evidence report and the technical evidence report is sufficient to prove that some person is committed the crime. And basically, those non-technical evidence are more strong. Basically, we cannot say those non-technical evidence is more strong than the technical evidence, but these are the written proof that someone has committed that particular crime. Now, there are the various branches of the forensic science. That first one is the computer forensic. The second one is the network forensic. The third one is the mobile device. Fourth is the digital image processing, and fifth is the digital video audio forensic and memory forensic. When we talk about the computer forensic, and this computer forensic deal with the computer system that may be used for the various purpose, such as sending the information to other person, and sending the some unwanted information to the other rival person in the company. And when we talk about the network forensic, the network forensic involve the identification of the attack that may be done by the intruder person or other person, and this network attack may be in the form of virus or malware attack and other attack. When we talked about the mobile device forensic, basically we identify the mobile device location, SIM card number, and IMEI number. These are the some forensic that is used in the mobile device forensic. When we talk about the digital image forensic, basically digital image forensic is in today's prevalent scenario is the most important forensic, because you can know several person uh, uh, by morphing technology, can add some person face in another person face, and try to blackmail those person. In those particular case, the digital image forensic technique is very useful. In digital image forensic technique, basically we try to backtrack the image. Basically, we can no, every image has its impression. The you can in easy word you can say that every image has its segmentation in the background. When we backtrack that particular image in the segment in the uh, back propagation method, we can easily identify that the other person has morphed or overlapped some other person face on the another person original image. When we talk about the digital video audio forensic, this one is the most prevalent evidence that is presented in the court against the criminal. But you can see in this is the most prone to tampering. Basically, various kind of tools and techniques are available that can easily hamper the uh, audio and video proof of the original message. Now when we talk about the memory forensic, basically when some person committed the crime or send the confidential information, when we talk about the in the Indian scenario, when the terrorist send the information, confidential information of the India to the other person, in that case the forensic expert, the digital expert, basically search their laptop or their digital devices, and their digital devices they first identify what what are the content in the RAM at the present time. Yeah, now we come on the forensic process model. Basically, first I define what is the forensic model. Basically, forensic model, they are based on the different phases, and these different phases containing the different a set of step, and this step easily identify the valuable and effective evidence against the culprit of the crime. So this is the nothing but the forensic model, and there are various forensic model there that are proposed by the various author. First one is the model one that was the proposed by Edmu et al. Second one is the proposed by the Mark et al. And the third model is the proposed by the KDM and the all. Similarly, there are the seven model. They are proposed by the various author, and they are basically based on some prevalent and predefined model. Yeah, when we talk about the model one, the model one was basically proposed by the Edium et al. And basically, this model was the refinement of the DFRWS model and IDP model. And it is, you can say, the enhanced version of the RDFIM model. And this model has the several advantage and disadvantage. Basically, the advantage are, you can see there are several advantage of this model. Basically, it provides the consistent framework. Then it provides the consistent mean that investigator will interact with the available source. Available resource means the available data that the investigator collect from the various resources. And then after collecting that data, the investigator can test that particular data using the exploratory method. And after that, the investigator used their own method. That may be their investigator own method or the other prevent method for testing the evidence against the crime. And the main disadvantage of this proposed model is the generality of this model is not explicit. Means that this model basically identifies the evidence against the culprit, but it is not suitable up to the mark. Yeah, when we talk about the model 2, this model was proposed by the market all, and this model is the refinement of the DFRWS model. Basically, basically in this model, there are lots of stages that was not possible to insert those stages in this PPT. So I am talking about that in this model particularly, they first preserve the data on the crime scene, then they survey the collected data and evidence, then they compile the document evidence, and they search again for the evidence. And after the searching of the evidence, the crime scene, they reconstruct the crime scene, and after reconstruction of the crime scene, they identify they identify whether the reconstructed crime scene is similar to the previous one or not. Yeah, when we talk about the model 3, this model 3 was proposed by the Guardian et al. Basically, this model third is the combination of the other prevent models such as DFRDM and IPDM, and this model has its own advantage. Basically, in this model, a various tool can be used for examination of the evidence. These tools may be image evidence tool or the recovering of the deleted evidence tool. But this model also has some demerits. As you can see, we have to record the activity in the step-by-step format. Yeah, when we talk about the model 4, this model 4 was proposed by the Brain et al. This model 4 is also refinement of the other previous model. Actually, this model basically give the accurate result for digital investigation purpose. and this model also have some disadvantage. Basically, the disadvantage of this model is the you can say that in this model the researcher or the investigator has to survey and the research the crime scene. For example, it is like to identify the hair in the large carpet, and similarly in the when we talk about the digital forensic, suppose we have the several TB of data, and in that several 100 GB or 100 TB of data, we have to identify the particular problem. So this is the disadvantage of the model 4. And when we talk about the model 4, this model was proposed by the Tushabe and all. And when we talk about the model 6, this model proposed by the Agrawal et al. Author, and basically the model 5 and model 6 is the further refinement of the other prevalent model. Yeah, when we talk about the model 7, this model 7 was proposed by the Ray Daniel and et al. Basically this model doesn't compare the any existing model. This model was basically self-driven by the author, and this model just tell the flow-based methodology, means that what was the flow of the crime. Basically, it just tell the flow of the crime, means what was the first incident, then what was the second incident, then what was the third incident. Then after collecting those steps, it identify the conclusion. Yeah, here you can see the comparative analysis of the digital forensic process model. We can say that the DRFW and abstract model is the more strong model as compared to the other. And this table also shows the comparative analysis of the forensic model with respect to the attribute. Attribute means here the various kind of step that is involved in the forensic model. As in the previous model, there was only a few attributes when compared with the today's prevalent forensic model that has lots of attribute to identify the culprit or criminal. So now I come to the conclusion. Basically, digital forensic is very important. The solving the crime, as in the inauguration session, mem says that we have the various kind of era in the several year ago. We don't have the computer, we don't have the iPod, laptop, and other things. We just communicate with using the telecommunication and pager technology. But with the advent of the technology and computer system, networking, and various tool and technique, there is a chance for there is a more chance of cyber crime, digital crime, and this crime is also well organized. And so this crime may be associated with the digital device, and this crime may be against the digital device, as we can see in the case of a bank, when some person try to communicate with the person over the telephone and identify their ATM number and OTP, and then withdraw the money. And for digital forensic, various kinds of tool and technique are available. Much of them are very prevalent in the case of image diagnosis, and in networking attack such as denial of attack and packet attack. And but regardless of this prevalent technology and tool, we have to identify some other kind of tool that can easily identify the culprit and the criminal. So we have to perform more research. Thank you, ma'am. These are the references. Any questions, sir? Hello.
Tarun, one question from my side. You learn any tool of any digital forensic or any technique?
Yeah,
You
ma'am.
just
Actually,
gather the only the assessment.
Yeah, ma'am. Actually, I work on the network analysis part, and me and my colleague created a device that can hamper the that can hamper the network. Means, suppose we are doing particular kind of thing in our network analysis, by using the device we created, we can easily identify the what kind of work he is doing in his laptop. And even after identifying the work, we can even jam their network, and we can add our unintentional message in their particular message.
Which tool you are using?
Basically, ma'am, we are using the Intel Neural Network Stick and Zigbee technology, ma'am.
And any technique that you are implemented? No technique, any name of the technique out of the 7 models, you are using any technique?
Basically, ma'am, these are the model to identify the crime. So we can use any of them, but we are using the DFRW technique, ma'am. These are
Why?
the ma'am, this technique is most efficient than the other, because this technique provide the step by step scenario of the scene. Suppose, ma'am, in our created device, ma'am, we first identify the kind of particular laptops or device that is available on the local network, and then we try to brute force attack on that particular devices. And attacking uh, after attacking and selecting those device, we try to hamper their message and even jam their network.
Okay, okay, Tarun. Okay. Good luck.
Thank you, ma'am.
Any other query from audience? I request participants to ask their query from the presenter. So if there is no query, we'll move to the next participants. Thank you, Tarun, for the nice presentation.
Thank you, ma'am.
Next presenter is Mr. Yasho Vijay Singh Yadav. Paper ID is 6. Title of the paper is Inserted C and H
Yes,
dielectric
ma'am.
resonator antenna having omnidirectional pattern excited by microstrip feeding. So Yasho Raja Singh is available, and I request, please, Vijay.
Good afternoon, ma'am.
Screen. I welcome you all in this conference. Please share your screen.
Thank you, ma'am.
Vijay, your screen is not visible. Kindly share your screen, and please introduce yourself also.
Good afternoon, everyone. That's Yasho Vijay Singh Yadav. I am from IST Shivpur, MTech second year, IST Shivpur. Ma'am, is it visible to everyone?
Yeah, it's visible now.
Okay. So that's Yasho Vijay Singh Yadav. I am from IST Shivpur, MTech second year. So the topic of my title of my project is paper inserted C and H band dielectric.
Actually, all handouts can be seen. You just make it in display mode. Put it in display mode. Single PPT mode.
Okay.
Slideshow, yes.
Ma'am, is it changed?
No. Select the slideshow.
No.
So it can be
from the beginning. Yes.
Yeah. It's now
Yes,
okay.
Good afternoon, everyone. Good afternoon, everyone. That's Yasho Vijay Singh Yadav, and I am from IST Shivpur, and the title of the topic is of the paper inserted C and H band dielectric resonator antenna having omnidirectional pattern excited by microstrip feeding. So what are dielectric this all is the content of the presentation. Introduction to DRA, properties of DRA, advantages of DRA, proposed antenna configuration, numerical investigation, simulation result and acknowledgement, and references. So what is DRA? DRAs are believed to have that nomenclatures in 1980s as the needs and thus the generation of wireless communication proceeds leads to the necessity of rapidly moving towards 5G technologies, and India might have a 5G till 2022. So DRA is a prominent component for the 5G technology. And the use of DRA was being initially propagated and started by Professor S.A. Long in the early 1980s, and since the FCC, Federal Communication Commission, has allowed the band of 3.1 to 10.6 gigahertz as an unlicensed band. So it is a trend in the modern researchers to work upon it. So now moving to the next slides. What are the properties of DRA? See, there are two types of antenna which are widely classified into two types. First one, printed antenna. Second are DRAs. So properties of DRAs are the distinguishing features with respect to the printed antenna and DRA. They are smaller circuit size, so the overall cost is reduced with comparable performance. And the most important, DRA can be designed in any 3D shape, having more geometric parameters, had degree of freedom. Degree of freedom is the essential component which directly affects the matching bandwidth. We will see in the later on in the simulation results how does this affects. And third point, DRA is made up of a high dielectric constant with no conducting parts, has very small dissipation loss. Therefore it can handle a high power. And the fourth point, as I said, that the smaller size of DRA makes that a dielectric constant as high. Another essential feature is DRA can be linearly as well as circularly polarized, and the most important, DRS operating at their fundamental modes, just rated like a magnetic dipole, a figure of 8, independent of the shape. Shape can be any rectangular shape, cylindrical shape. The first one which Professor Long described, that was cylindrical DRA, but the pattern, but in the fundamental modes, the pattern is always like a magnetic dipole. Now the next slides. What are the advantages of DRA? First one, as I described, all the comparison mentioned here are with respect to printed antennas. So advantages of DRA, number one, smaller form factor. Why? Because the size of DRA is directly proportional to the lambda naught by root of epsilon naught, where lambda naught is equal to C by F naught. Whereas in the case of printed antenna, it is directly proportional to lambda naught. So here the DRA has a smaller form factor. Next point is DRA are suitable for higher band up to 300 gigahertz as they have very high radiation efficiency. Number third, the large impedance bandwidth. Now as my title suggests, that C and H band, the band nomenclature has been taken from waveguide frequency band, whereas the range of C band is from 5.85 to 8.20 gigahertz, and H band is 7.05 to 10.10 gigahertz. If the nomenclature has been taken from IEEE band. Then the C band ranges from 4 to 8 gigahertz, and the X band ranges from 8 to 12.4 gigahertz. The same. Now moving to the next slide. Proposed antenna. This paper presents a novel inserted C-band and H-band dielectric resonator antenna with omnidirectional pattern and a higher bandwidth excited by microstrip feeding. A parametric study on the width of antenna is been performed, along with the effects on parameters of performance of antenna are being investigated, and subsequently simulated result are being presented. Figure 2.8 is the isometric view of the proposed antenna. B is the top view where the name F1, the parameter F1 is been studied, and the width of W is been monitored in its simulation results. And the third one is the side view. And the port assigned to it is a lumped port. Now moving to next slide, the proposed antenna configuration. Width of antenna has been, it's 12 mm, and the width has been taken by the reference number 1, reference paper number 1, along with the length of DR is 13 mm, height of DR is 5.08 mm, and RT 6002 substrate with the dimension of 15 to 32 mm square with a dielectric constant of 10.2, and the most essential factor, the dimension of ground. Yes, the dimension of ground too affects the matching impedance bandwidth, which I have presented it in the next slide. We will see this. And thickness of DRA on the feeding side is 2.54 mm, and the thickness of DRA on T2 is 1.77 mm. Now next slide. Numerical investigation. The proposed ultra wideband DRA, the range of ultra wideband is 3.1 to 10.6 gigahertz as per its IEEE standards. So, and what parametrically analyzed using F1 as parameter. I would away this here, in the top view, figure B, F1 is been parametrically monitored. F1. So there were 3 solution setups, namely solution setup 1 with the solution frequency of 3.1 gigahertz, and setup 2 with frequency of 7.1 gigahertz, and setup 3 with a frequency of 10 gigahertz. So there were 2 cases of F1 that were analyzed, F1 equal to 6 mm and F1 equal to 4 mm. So now the first word of my title, that was inserted. What does that inserted implement? Suppose when a dielectric resonator is placed on the top substrate, then it is known as planar DRA. On the other end, if a DRA is positioned inside the substrate, it is termed inserted DRA. And since as per according to reference 1 and 2, the symmetry of DR, a dielectric resonator around the excitation, is very needful for the omnidirectional pattern. And the orientation of ground planes to affect, as I mentioned earlier, the thickness of microstrip affects the reflection coefficient S11. Now moving to the next slide. These are simulation results. They are being converted into 2 parts. The part which is on the left hand side of your screen, it contains F1 with that range, top range at 6 mm and F1 at 4 mm. A very interesting result was found. All the solution are being set up by the software HFSS, ANSYS HFSS. So here we got a S11 plot, reflection coefficient plot. So the first setup, this is for the first setup, that the setup one where the operating frequency is 3.1 gigahertz with F1 equal to 6 mm, and on the right hand side we have F1 equal to 4 mm with the same solution setup operating a frequency 3.1 gigahertz. So here the matching bandwidth was comparatively formed with the range of ranging from 5.2 to approximately 10.7 gigahertz, means the total X band, the total C band and H band were being covered from it. And a subsequent similar result was formed with f1 equal to 4 mm, but there is a slightly change, as you can see that after the frequency of 7.5 gigahertz, the curve with 6 gigahertz has a declining shape, has a concave shape, whereas after 7.5 gigahertz, the curve with f1 has a convex shape. The reason for this is the cross polarization. Since here with the slot being 4 mm, there were two air slots introduced into the pattern, so that air slot affects the matching, and here the matching bandwidth is comparatively low. With f1 equal to 4 mm, the bandwidth is slightly reduced by 1 gigahertz, whereas with the f1 equal to 6 mm, the bandwidth is completely covering the C and H band. Now moving to the next slide, it contains gain plot. It has gain pattern with phi equal to 90 degree. This is again the left hand side deal with f1 equal to 6 mm, and right one side deal with f1 equal to 4 mm. In the gain pattern, phi equal to 90 degree as was figure 5. Here a constant omnidirectional pattern, a figure of 8 has been formed, and a similar figure is been formed in figure 6, where the f1 size is 4 mm. But since the setup change to setup number 2, now the gain pattern as per its figure number 7 has a pattern of 8, but the values are increasing. Since the visibility of Google Meet platform, I was unable to magnify it, but the figure, since the figure expresses the figure of 8 is not that much appreciable. It is appreciable, but not an exact figure of 8 has been formed. There is a bit of pattern mismatching, and but the similar values were obtained with f1 equal to 4 mm too. Very slightly change were being observed. Now moving to next slide. This is a very important slide. This is figure number 9. It just contains the gain radiation plot for setup number 3, phi equal to 0 degree left hand side and phi equal to 90 degree right hand side. Phi equal to 90 degree taking first. Although the pattern here is not a complete figure of 8, there are few side lobes available, but the lower half of figure of 8 is been maintained. This can be countered by the fact that the here cross polarization is playing a very prominent role. After the frequency of 7.1 gigahertz, the effect of cross polarization is highly observed in the DRA, and that too is followed in my proposed antenna. Whereas with phi equal to 0 degree and f1 equal to 6 mm, the as per Professor Long in 1980s also commented that cross polarization is a consideration in an antenna design. So here another, just moving to the next slide, what was the result obtained? The proposed inserted DRA for C band, that is 5.85 to 80 gigahertz, and H band, that is 7.05 to 10.10 10.10 gigahertz, as per as waveguide frequency band, has minus 10 dB bandwidth over the entire band, and proposed antenna possesses omnidirectional pattern over the entire desired range of operation. So the proposed inserted DRA has been up to the mark as per its simulated results since the lockdown. So the lab work is the lab measurement are yet to be taken, but this all or but a simulated result for the desired C-band and H-band application. Along with that, there is an important conclusion to be drawn that width of inserted strip doesn't affect much the S11 plot with the microstrip feeding. The conclusion number 2 needs a very higher attention, that with microstrip feeding there is not a much of effect on S11 plot, but with CPW feeding, yes, there is a effect that is not mentioned in the in this paper. But yes, with the feeding, with CPW feeding, the thickness of it will affect the pattern. Also the third most consideration, that the ground plane, mm, the dimension of ground plane very significantly affect, because when the similar dimension were taken, just a second, I will take you to the that part. Yes, the dimension of ground, that here in the proposed figure it is 15 cross 18.5 mm square. When the similar with all this characteristic, the dimension was just changed with 14 cross 18.5 mm square. The bandwidth show a notch. We we got a notch at the frequency of 8.2 gigahertz. So from there from there a desirable conclusion can be drawn that the orientation of ground slightly affects the or affects the pattern of the matching. Acknowledgement, yes, for the support and motivation, Professor Dr. P.K. Singhal sir and Miss Arpita Mittal. So references part, these all are the references, and thank you. Any questions?
Thank you, Vijay.
Yes,
I would like to ask one query. In I think in third slide you said that DRA is suitable for band up to 300 gigahertz, but your proposed DRA is implemented for C and H work. So can you
yes,
tell me the difficulties for using DRA other than these two bands?
yes, ma'am, till X band also it it works fine. But now
Mhm.
after the means after 12 gigahertz, there are three issue, basically cross polarization, and after the X band there co-polarization is also reduced. So so these two affects it. So we are not able to use it as operational as on millimeter wave. So these two affects it's a lot. Cross polarization affects it a lot. And as per the reference number 1, the cross polarization affects after X band to a maximum extent, which was been visible after the slide number 7, also in the setup number 3, where the operating frequency was been chosen as 10 gigahertz.
Okay, so this must be your thesis work.
Yes, sir.
Okay, good luck. So
Thank you.
any other query from the audience? So, okay, if there is no query, so Dr. Abhiruchi is also ready with the presentation. She has paper ID number 1. So her title of paper is Brain and Computers. So now I would like to invite Dr. Abhiruchi for her presentation. Dr. Abhiruchi? Dr. Abhiruchi, are you in meeting? Just now she had messaged me that she is ready with the presentation. The second author of that same paper Is in meeting?
Yes, ma'am, I am.
Madhu Soni.
Yes, ma'am, I am the author, and ma'am is disconnected suddenly, ma'am. I am working on it.
So you
Give
are
me a
going to
minute.
present? You are going to
Yes, ma'am.
present?
Just give me a minute.
Okay, no issue. So Madhu, introduce yourself, and you have 10 minutes. It's 1:13 and we have to conclude it because okay, let me one more paper was left as per this schedule. Is Mr. Tarun Agrawal is in meeting with paper ID 4, a CPW fed up cup shaped UWV antenna for the application of next generation communication system. Tarun Agrawal or any other author of this paper? Okay, Madhu Soni, you can start your presentation.
Ma'am, just wait a minute. I am connected from an Android device and I can't show my presentation. So my Abhiruchi ma'am will show it and I'll speak. Just wait a minute.
So Abhiruchi ma'am is in meeting. As I
Ma'am,
can
she
see
is
the
coming. She
participant
got
list.
disconnected due to an error. Just wait a minute. It's an internet issue, ma'am.
Yeah, just try to resolve it because it's already 1:15. We have to conclude this session by 1:15. After lunch break, we have one talk and then technical session 2 is also scheduled.
Okay, ma'am. Just a minute.
Dr. Lakshmi, I
Yes.
think Dr. Abhiruchi and Madhu are not able to make the presentation.
So
So,
Madhu is trying. Madhu, could you present?
Ma'am, just a minute. You gave me 10 minutes.
10 minutes.
Include
We
this
can't
time
take
in
10
that.
minutes. You are the last
Ma'am, you gave me
presenter.
10
And
minutes
time is
total. In total, please include that time, this time in that too. Because I need less than 10 minutes for my presentation.
Sir, can we give time to him, Madhushoni? Single, sir?
please, yes, please continue. Please.
Yes.
Hello. Good afternoon, ma'am.
Yeah, Dr. Abhiruchi.
Yeah,
Yes.
sorry, ma'am, I got disconnected. Ma'am, can I share my screen now?
Yeah, please. We are
Yes,
waiting
ma'am.
for you.
Yeah. Sorry, ma'am. I'm really sorry. Ma'am, is the screen visible?
Yes, yes, it is visible.
Okay. So very good afternoon to all of you. Me along with my student Madhusudan,
It's
we are going
not
to
to me.
give the presentation on brain and computers. Over to you, Madhusudan.
Yes, ma'am.
Madhusudan, kindly be a little loud.
Yes, ma'am.
Yes, please.
Ma'am, hello everyone. We made a presentation on brain and computers in which we discuss both their workings and their similarities and differences. And the general concept of it is that we are comparing human brain and computers. They both are considered very complex and vast piece of technology. And brain is obviously, as we all know, is a human body creation, and computers are a creation of human brain. And human brain is the most important part of our body. It performs all the calculation, mental work, body control, our behavior, and all other activities performed by us. These all are these all are controlled by our brain. And it's like the whole body is a controllable object, and the brain is the one control center designed to control it or make it work. And the brain have fundamental units which are known as neuron, which perform logic, data, and operations in a
Sorry for
pattern
interruption.
formation,
Dr. Abhiruchi, we are getting some noise, background noise from your
which are
device.
formed in pattern. And then we have computers. The computers are the machines created by
Sorry for
by
interruption, Madhu and Dr. Abhiruchi.
Yes, ma'am.
We are getting some background noise from your end. So if you are
Okay,
just
ma'am.
checking your screen, so kindly mute yourself. And Madhu, please you speak.
Sure, ma'am. I'll
Okay,
mute
ma'am.
myself, ma'am.
Yeah.
And then, ma'am, we have computers. Computers are generally the machines created by combining various parts like the CPU, memory, storage, graphics, etc. And ma'am, these all parts are unique in their own way, and they have special qualities and functions. And when combined, they all make a general purpose machine which we use in our daily life, which is known as computer. And ma'am, it's a very smart machine, or there is a comparison between brains and computers, ma'am. Generally, these both are very similar yet work quite differently. Like computers are great in logic, and brain is great in imaginative tasks. Brain, there is a quick fact in these that brain starts working from our birth to our death, but computers can be turned off or on at any time. And when computers have a special quality, like they are very good at multitasking, whereas our brain is good in only single tasks. I like doing one task at a time serially. And when they both work and store data on electric current, or when however computers get direct electric current supply while our brain generate electricity through chemical reactions. And after these, there is a conclusion. Overall, these two are quite similar or quite different. They both work in similar ways yet differently. They both are based on similar concepts, but their working and specialties are quite different from each other. And when computers are generally considered as machines with brain which are created to simplify our daily life tasks. And when there are two references, and thank you. Any questions?
Any questions from the audience? Okay, if there is no question, thank you, Madhu. Thank you, Dr. Abhiruchi. It's 1:30, and in this session we had As per list, there were total 6 papers and only 5 candidates could present their paper. Again, I would like to call paper ID, author of paper ID 4. That is Mr. Tarun Agrawal. Is he in meeting? Okay, he's not in meeting. So, with due permission of Singhal sir, can we end this technical session, sir?
Yes, madam. Thank you very much for sharing the session, and you and Dr. Vijay Lakshmi.
Bhavna Srivastava, sir.
Thank you so much, sir. It's a nice session. Enjoy all the papers and get more knowledge regarding the different fields of research. Thank you so much, sir.
Thank you. So thank you all the presenters. Now at sharp 2 p.m. we shall again rejoin. First of all, we have a very interesting keynote address, then paper presentation will continue. And a small announcement I have received request from few participants that due to working day on Saturday, they are not able to make presentation today. So we shall accommodate their paper, reschedule their paper tomorrow. And if time permits, if any of the speaker is having any idea, technical idea, he or she can request and we shall allocate some time schedule for proper presentation. So thank you very much. We shall rejoin at 2 p.m. after lunch. Thank you.
Thank you so much.
Thank you, Lakshmi ma'am.